All right, welcome back to the last week of circles. As you can see on the board, things are getting out of hand, but it's all right. Y'all know we have a test on Thursday, right? So we're going to make sure we're getting ready for this test on Thursday. Today's the last new thing we're learning. Tomorrow you'll have an opportunity to make sure you've finished all your assignments, okay? And if you look at the sliding whiteboard, these are the three that are not in the grade book yet and will be very soon. So that's Thursday, Friday, and then today. So it's all three on the board here. Wednesday we'll be reviewing because Thursday is the test, okay? And if you're already caught up by tomorrow, then you can start the review early. That'd be smart, right? So let's do this. Today we are talking about segments in a circle. So not segment of a circle. I know we've done that before. That was on Thursday, I believe. Let's see here. What happened? Okay. Segment in a circle. So we're going to keep the notes as simple as we could possibly keep it, given that this stuff can be complicated. So let's do this. Sorry, it's taking forever. So at the top of this sheet, it says segments of circle notes. And then it says rules dealing with chords, secants, and tangents in circles. So the first thing we're going to talk about is intersecting chords. As it loads. 10 years later. Cool. Alright, check it out. If two blank intersect. So it's kind of obvious by the title of this little section. If two chords intersect. And if you remember the first day we did circles, we learned what a chord is. Does anyone know what a chord is? They can tell me right now. All right. Well, if you look at the picture right there, there's a hint. But a chord is a segment within a circle, right? The endpoints are on the edge of a circle. It has no arrowheads. It doesn't go outside the circle. It's all inside a circle. Okay? So, if you got two chords in a circle, the blank of the links of the segments. Okay? So basically, the two parts of that chord are going to be multiplied. We call that the product. The product of the links of the segments of one chord equal, right? We got an equal sign right here. And once again, product of the segments of the other, okay? So, if you look at the picture right here, A times B, so this little part times this little part, equals C times D, this little part times this little part, okay? So that's the rule. Let's see two examples, okay? So example one, I look at this circle. I see that I have two chords because they're inside the circle, right? So I take one of my chords and I say, hey, this times this goes on one side of my equation. So 3 times x equals, and then for my other chord, I multiply those two numbers. 2 times 6. Do you see how I set it up if there's two chords? Little part times little part on the same segment, same chord, equals little part times little part on the other chord. Let's do some math here. 3 times x is 3x, right? What's 2 times 6? 12, okay? One last step to get rid of that 3. What do? Divide by 3. And x equals what? 4. 12 divided by 3 is 4. Was that hard? Hopefully not. You just got to know the rule. So I'm telling you the rule, and on your test, I'll give you the rules. Okay, we're gonna have like a special circles formula chart just in case, right? If you look at number 2, are those 2 chords? Yes. So since these are 2 chords inside of a circle, do the same rule. So this little part times this little part on the same chord, right? 4 times 9. And then equals, on the other chord, this little part times this little part. X times 6. When you write multiplication, the order doesn't matter, right? 4 times 9, what do I get? 36 equals, now x times 6 is the same thing as 6 times x. It's going to be 6x. And how do I get rid of that 6? Divide. 36 divided by 6 is 6 equals x. That's it. Okay. So if you have 2 chords inside a circle, that's how you do it. Okay. Now that's one thing we're learning. There's 2 other things we got to learn today. There's 3 different scenarios. So this was 2 chords. So what if we have 2 secants, right? So let's read this. It says, if 2 blank segments, okay, are drawn to a circle from the same external point. Okay? So if 2 secant, right, segments are drawn to a circle from the same external point, the blank of the length of one segment and its exterior part. Now, this is where this one can be confusing, okay? So I want you to look right here. Does everyone see the letter B right here? And this dashed line. B is not just on the inside. B is the inside and the outside combined. It's what we call a total, right? The total of the length. Or the, yeah. I'm not sure exactly what other word you would use there. The total of the length of one secant segment and its external part, okay? Actually, back up. Its product. I steered you wrong there. It's the product of the length of one secant segment. But this is the total length, okay? I cannot stress this enough. You take the whole thing, and you're going to multiply the product. Multiply by just the external part, which is A, okay? So does everyone see that right here? A times B. Outside times whole thing. Which is equal to, on the other one, it's the same idea. It's the product of the length of the other secant. Now again, that's the total length. So if you look at letter D down here, right here, all the way, okay? And its external part. So that's why it's C times D, okay? So we're going to see how this works here on example 1. I want you to really pay attention and think about how you might mess this up. Not, you know what I mean, because it's easy to confuse. Let's look at example 1 right here, okay? First, let's look at on the left here. So on number 1, what is the external segment? 3, right? So I'm going to put 3 times, what do you think I'm going to multiply 3 times? Who thinks I'm going to multiply it by 5? It is not 5. Remember, it's supposed to be the whole length. What is this whole length? 5 plus 3, right? Do you see how that's that can be confusing if you just look at it. You're like 3 times 5, duh, right? You only do that if it's like the 2 chords. 2 chords, that's when you do it. It's obvious. It's easy, right? But I'm telling you, if you're doing secants, where you have little numbers on the outside, that's different. Okay? So the whole thing here is 8. 5 plus 3, right? So 3 times 8. That's where people mess up, right? Equals, here's another tricky one. Okay? What's on the outside here? 4. And does everyone agree x is not the whole thing, right? But what is the whole length here? It's not 4x. That's multiplying. Okay? What we're going to do with x and 4 is add them together. Now, if you add x and 4 together, you get x plus 4. It's literally, you can't combine them. They're not the same thing, right? So, as weird as this looks, this thing is x plus 4. Okay? So I'm going to actually write parentheses x plus 4. Okay, which I know is kind of weird. Oh my gosh. Okay. So does everyone agree? I did outside times the whole thing equals outside times the whole thing. So what is 3 times 8? 24. Equals, now what do I do with a number outside of a parentheses? I'm going to multiply it, and it's called distribution, right? Distribution. 4 times x? 4x. 4 times 4? 16. It's positive, so plus 16. Okay, now this is a little bit slightly more complicated than before. It's just a 2-step problem, but we can do it. Let's just remember how to do this stuff. X is on the right side. Do I get rid of the 4 or the 16 first? The loner is 16, so to get rid of a positive 16, we subtract 16. What's 24 minus 16? 8 equals 4x. Now what's my last step? Divide by 4. So 8 over 4 is 2. Oh my gosh. Hold on. Okay. So do you see how the secants can be a little bit more involved, right? Let's try another example on the next page, okay? If you need a second to get this down, get it down now. You got like 10 seconds. But we're on the next page now. On number 2. Here we go. All right. So on number 2. What's my rule again? Outside times what? The whole thing. So what's on the, let's go on the left here. What is this outside one? So x times, what's the whole thing? X plus 7. Right? You can't add x and 7, so you put x plus 7 in parentheses. Okay? All right, and then on the other side, what's the outside? Okay, 8 times, what's the whole thing? 14. Okay. So x times x is x squared. X times 7 is 7x. 8 times 14. 112. Oh my gosh. Okay. Okay. Now this is a more complicated problem in which you would have to do quadratics, and y'all remember from Algebra 1 having to factor quadratics? See a lot of no's. Alright, so here's the deal. On your assignment, you're not going to have to do one this complicated, but at least you saw us set it up. Okay, let me double check this real quick. Yeah. You're good. Okay, so we're going to stop number 2 right there, okay, alto, only because you're not going to see one of these, okay? But you could presumably get this to equal 0 by subtracting 112, and then you would factor that, okay? But again, we're going to stop that problem right there, okay? Hopefully near the end of the year we can get some review on factoring, because in Algebra 2, you're going to need to know how to do that, okay? Or at least use the quadratic equation, my favorite thing. Okay, look at secant and tangent, please. If a blank segment and blank segment, okay? So, if a secant segment and a tangent segment are drawn to a circle from the same external point, okay, as you see, the blank of the length of the secant segment, okay, so again, we're talking about the product, and its external part equals the, now this is different, A has no internal, it's just one thing, right, it's tangent, so what we're going to do is take that A and we're going to do this, which is square, right? The square of the length of the tangent. Okay? So, let's do that. Again, this is a unique situation. One of these is secant, one of these is tangent. Okay? One is in and out, one is only out. Okay? So that's when you use this rule, when it looks like this. So let's start with the secant. So what's on the outside of the secant? We got 4, right? And then what is the whole thing? X plus 4 equals, and what am I going to do with that tangent again? Squared. So the tangent over here is 8, and I'm going to put a squared on that. Okay? Cool. So 4 times x, 4 times 4. So 4 times x is 4x. 4 times 4 is 16. And 8 squared, 8 times 8 is 64. Two-step problem. Over here in the front on the phone, what do we do first? To get rid of that positive 16. Okay, minus 16. And we get 4x equals 48. And my last step to get rid of that 4 is divide. What do I get? 48 over 4 is 12. Last one on the notes here. Let's go to the secant again. What's on the outside? 2. What's the whole thing? 2 plus 16. 18. So 2 times 18, outside times whole thing, equals, and what do I do with that tangent? Square it, right? So y squared. So what's 2 times 18? 36. equals y squared. And how do I get rid of a square? 16? For what? Yes, because this right here? No, because it's the whole thing. You do the 2 plus the 16 to get the 18. Okay. So yeah, this 18 is correct. It's not 16 because it's supposed to be outside times whole thing, 18. Okay. So, all right, and then to get rid of a square, we square root. And what is the square root of 36? 6. Okay. So, again, the only thing on these notes that I exposed you to that you don't have to actually have on the assignment is number 2 on the top of the second page, the top of this page right here. So again, you're not going to have one like this right here. Okay. So on the next page, it's the assignment. So again, you can separate those. Please separate them because I don't want you to turn in these notes. Keep these. Okay. So if you separate your notes, you'll see you've got 12 problems. You got 4 of each. There's 3 sections, right? I somewhat scrambled them up, but it's kind of obvious what's going on. But you can do it, okay? So look at your notes, follow the rules, and ask good questions, okay? Let's do it.